Hi everyone, this is lesson 513 from the Integrated Math 3 textbook on more inverse functions. At this point we've introduced inverse functions, we've looked at how to write them, we've looked at inverse functions on graphs. Here's a little bit of a quick reminder of the general idea of inverse functions. We look at this idea of a function kind of like being a function machine. And if we give it an input, it's going to give us an output. And the way an inverse functions is that it takes that same output as an input and should give you the same input we originally started with. So for example, if I plug in a 3 and it happens to give me a 13, and if I plug that 13 into my inverse, it should give me that 3 in return. So they're shown here stacked up for a reason, to kind of show you that if you connect them, the end result should always be that if you plug in a number, you're going to get that same number back. Okay, so this only works, this idea only works if this is truly the inverse of the original function. So the inverse may or may not be a function itself, but it will always be some type of equation that acts as the inverse of the original function. So we're going to look today in this lesson at still a little bit more writing the equations, the inverse of those functions, and then verifying that it is indeed the inverse. So algebraically, we could create this inverse, but does it actually work? We need to actually test it out, because it wouldn't make any sense if I plug in a 3 and somehow I ended up with a 10 in the end. Then that would mean that that's not an actual inverse. So we're going to double check that moving forward. All right, so I think I only have a couple problems for us to do. I've kind of started the process already on this one. We have a function 2 times x minus 1 cubed. All right, you'll notice it's an cubic function. We're going to start the process of rewriting this as an inverse. So here's a little bit of a reminder. Our first thing to do is to write it out of function notation and write it into an equation notation. And what I mean by that is to actually write it in terms of x and y. So instead of just in terms of x. All right. So here we have our new updated equation. Now, to actually write the inverse, it's really one simple step, and that requires us to swap our x's and y's. So it should look identical, except the only difference is I've replaced my y with an x, and I've replaced my x with a y. All right, nothing else has changed. So this technically is our inverse equation. We just have to rewrite it. So we have to rewrite it so we get to the point where we actually have y equals to something. All right. So the way we do that is by undoing all the operations that are being done. So you can look at this, if we're looking at this y, an operation that's being done is there's a 1 being subtracted from it. There's this cube that's being applied to the y minus 1. And then after that, there's a 2 being multiplied. So there's 1, 2, 3 different operations occurring that we have to undo. So now we have to do them, and we're going to do them in reverse order. So if we started at the closest, it would be with the minus 1. But I think I mentioned this before. We always want to start on the outside and work our way in. So anything that's on the outside. So the minus 1 is on the inside, so we're not going to do that. The cubed is on the outside, but also the 2 is also on the outside. So which one would we do first? Well, the cubed actually belongs to the parentheses, And so beyond that, you'll notice the 2 is actually outside of the parentheses. All right, so let's focus on the 2. If you do these in the wrong order, if you're not sure about your order of operations, you could end up with a wrong inverse. So I'm going to zoom into this for a little bit so we could focus on our next step. So I'm going to, since that's being multiplied by 2, I want to get rid of that. So I'm going to divide both sides by 2. This leaves us with an x over 2 is equal to y minus 1 cubed. All right, so now there's no more 2. So now I can focus on the exponent. So here might be a little bit tricky part if you're not familiar. If it was an x, or if this was a squared, some of you might know, we would probably take the square root of both sides. But since this is a cubed, to get rid of a cube, we would apply a cube root. So if you're not familiar, this is what it's going to look like. You should end up with, it's going to look like it has a radical symbol, except it's going to have this little 3. Kind of looks like an exponent, but it's in front. And then we'll have the x over 2 inside. So I'm going to put parentheses around that so I know they're together. And I'm going to be left with y minus 1. All right. So now I need to get y by itself. So let's add a 1 to both sides. This is going to leave us with y by itself. And we can't combine these together because they're not like terms. So let's keep them separate. So I'm going to write it with x over 2 cubed, or the cubed root of x over 2 plus 1. All right. So that's what we have so far. The remaining part would be to write it back into function notation. Oops, sorry. So let's go back. Let's see. Let me use a bigger. Sorry. All right, so we're going to do function notation. All right, so that means we're going to write this as an inverse, right? You'll notice a little minus 1 on the f is equal to, and I'm just going to rewrite this. This is the cube root of x over 2 plus 1. All right. Oh, that didn't shade. Well, it didn't quite work out the way I wanted. All right, so the next step for us is going to be to verify if this is correct or not. So it is possible, like what if we made a mistake? How would we know that it's a mistake, right? How would we know? They're not going to know, or will they know? So let's double check if this is correct. So the only way to find out is really to plug in numbers. So we have the original function. Let me copy the original function. So the original function, oops. So here's we have the inverse and we have the original function. Are they inverses of each other? All right, so it's kind of like the picture I showed you above where I had the two function machines stacked up on top of each other. Is it going to work? If we stack them up, will we end up with the same input? So the way we show this is I'm actually going to take this function and I want to plug in a number, and so the input is going to be the number 3. So I'm going to replace that x with a 3. It could be any number. It doesn't have to be a 3. It could be any number. I just chose 3 because it was a number in the picture from above. And so we would simplify this. And so we would end up with, oops. So let me do it over here so I have more room. All right, so if I simplify this, this is going to be, well, you could tell me. So this is going to be, you tell me what this equals to. So maybe you could do it in your head. Maybe you need to use a calculator. Either way, it's fine. So if you do it in your head, you're really going to test yourself to see if you know your order of operations. So tell me what that equals to. All right, let's see if you got this. So if we're doing this in my head, I would do 3 minus 1, which is 2. And so this is going to be the same thing as 2 cubed. 2 cubed times 2. I might actually rewrite that. So I'll put 2 times 2 cubed, which then gives us 2 times 8. Right? If you make the mistake of doing 2 times 2 first, that would be the wrong order of operations. You'll get a wrong answer. So 2 to the third power is 8, and so now we're looking at, oops, this is going to be 16. All right, so if we plug in a 3, we're going to get a 16. All right, so now if we're stacking up these functions, what we're going to do is I want to test out this new equation, this inverse, and see if it works. So I want to use this one, and let me rewrite this. This is cubed root of x over 2 plus 1. So I'm going to replace this number. Let's use those dark blue. So I'm going to put the 16, right? So you'll notice I'm just going to plug this 16 back into this new inverse, right? This is the inverse. So that means I'm going to put a 16 here instead of the x. And now we have to simplify this. So it looks complicated. Maybe you might think, oh, I can't do that. Well, take it one step at a time. We're going to focus on that fraction. So let's see. We should have, oops. So this is going to be 16 divided by 2 is going to be 8. So it's the cubed root of 8 plus 1, right? It helps if you show each step. That way we know if we make a mistake where to fix it. Now we need to know the cubed root of 8. Now if you don't know that in your head, then that's something you could try to type into the calculator as well. So just like a square root, it's the cube root. What 3 numbers can you multiply together to give you 8 that are all the same number? Well, that's going to end up being, 2. So this is 2 plus 1. So this is like 16. All right, so the last one is, let's see, this inverse is going to equal to 3. All right, so if we plug in a 16, it gives us a 3. You'll notice, hopefully if we did this correctly, this 3 should be the same 3 that we plugged in initially. All right, we got the same number. Awesome. Which means, therefore, this is the inverse. All right, this is an inverse. That means we did the first steps correctly. All right, so we're going to try to do this again with another function. So now that you get the general idea of kind of what we need to be doing, so can you rewrite it? That's one thing. And then can you verify that they're actually inverses? So let's look at a new function and see if we could do that. All right. All right, so here we have f of x is equal to 3 times the quantity x minus 9 divided by 2 plus 20. Now, there's no square or cubed on any of this, but there's a lot going on. I noticed right away that there is a 3 being multiplied. There's a 9 being subtracted. There's a 2 for the division in the fraction, and there's a plus 20 being added. So I see 1, 2, 3, 4 different operations we need to undo, which means when we're writing the inverse, there should be 4 steps to this. All right, so I started this already. First step is to write it in equation notation. So I've replaced the f of x with a y. That's the only thing that's changed. And then I've already got a head start on swapping our x's and y's. So it should look identical except for the x and y have swapped places. All right, so the rest of this is just rewriting it. And so let's see if you could do this or you could follow along. All right, so I'm going to zoom into just that portion for a little bit. So let's see, do we start? Common mistake is, again, focusing on the inside. A lot of times we see like subtraction and addition and we want to do those first. Not a good idea if it's in the inside. So I notice there's a lot going on here, but the last thing is this plus 20. So that's the first thing I want to start with, the plus 20 on the outside. So let's focus on moving that. So I'm going to do minus 20 to both sides. This leaves us with x minus, oops, wrong, yeah, too dark of a purple. X minus 20 is equal to 3 times y minus 9 over 2. All right, so now there's a 3 in front. I want to get rid of that 3. Easiest way to do that. You do have an option to actually multiply this 3 inside. That's a possibility. It's not always helpful. So it always seems easier just to somehow move this to the other side first. So the way we would do that is to actually divide, well, let's actually divide the whole thing by 3. All right, so then we're going to be left with x minus 20 divided by 3. You'll notice that divided by 3 goes completely under the x minus 20. Not just the x, not just the 20. So try not to make that mistake. We're going to be left with y minus 9 divided by 2. All right. We're almost there. So now we have a minus 9 and we have a 2 on the denominator. So try not to make the mistake. The closest thing is what is being done last. So let's focus on this division of 2. The opposite of dividing by 2 is to multiply by 2. So let's multiply both sides by 2. So we're going to be left with 2 times x minus 20 over 3 equals to y minus 9. Now there's going to be a temptation here. Some of you are going to want to start to multiply these things out. You can. It's not going to be wrong, but it's more work and it's more opportunity to make an error. So if you don't have to multiply things out, I would just leave it like that. The goal is really just to get y by itself. So now we only have one more step to this. We're going to add 9 to both sides. And everything's going to stay the same. And you'll notice there's plus 9 is going to be on the end. So this is equal to y. All right, I'll zoom out so you can see the whole thing. So you'll notice, I said earlier, there's going to be like 4 steps because there was 1, 2, 3, 4 things happening. So we move the 20, we move the 3, the 2, and then the 9. So there was 4 things we had to move. You'll notice the format looks very similar. That's always going to happen with linear equations. But you'll notice how things kind of get moved around. Some of it might be obvious, some of it maybe not so much. All right, so let's rewrite this in function notation. So this is going to change to inverse f of x. And I'm going to put 2 times x minus 20 over 3 plus 9. All right, so there's our inverse. That's what we think is our inverse, comparing it to the original. So I'm going to copy that. All right, so we want to see, are these really inverses of each other? So just to kind of give you the visual that what we want to do, actually I'll make this smaller, and I'm going to recopy this. All right. So let's see if I could draw this out for you. So what? All right. So what we're going to check to see is if I actually take in this, treat this as a function, and this other one as a function machine also. The question is it going to give me the same output? All right, so what we're going to try to do, we could plug in, let's see, what would be a good number we could plug in? I guess it doesn't really matter. I'll try plugging in a 3. I haven't tested this out yet. Hopefully this works. So if I plug in a 3, is it going to give me a 3 in the end? All right, so let's start this process. So I'm going to start with our F3. We're going to plug in a 3 to that first function. So it's going to look like 3 times, we're going to have something minus 9 over 2 plus 20. Oops. So I'm going to plug in that 3. So it makes it a lot easier if you actually rewrite it. Don't leave out parentheses. Don't leave out numbers. Fractions, stack them up the way they're supposed to look. Makes it a lot easier. All right, so let's simplify this. Tell me what this equals to, if you can. Our goal is to figure out final answer. I'll just set this up for us first. I might actually do this in a couple steps. All right, maybe there. We'll see. All right, you tell me what is this going to equal to? Final answer, what happens when we calculate that? All right, so if I'm doing this in my head, I'm starting with this fraction, which means we have to start on the top. So I have 3 minus 9. 3 minus 9 gives us a negative 6. And I'm going to take negative 6 and divide it by 2, which is going to give us a negative 3. So let me write that step out before I forget. So I have 3 times negative 3 plus 20. And so that means negative 3 times negative 3 is negative 9. So it's a negative 9 plus 20. So this is going to give us an 11, I believe. All right. So we're looking to take that 11 and plug it in. Let's see if we could take this 11 and we're going to plug it into our inverse. So let's use, I'm going to use my other color here. So I'm going to plug in 11. And let's see what this gives us. So let's set it up. We're going to have 2 times some number minus 20 plus 9, and that number we plugged in is our 11. All right, so let's see if we could simplify this. Oops. I'll probably do it in a couple steps again. All right, see if you could tell me what this equals to. Try to do calculations and see what you come up with. It might not be what you expect. And so let's see what you get. Practice. You might want to practice typing that in a calculator to see if you actually could type it in the way it looks. Alrighty. So let's see. I would probably start with the top first. So 11 minus 20. 11 minus 20 is a negative 9. So we have 2 times, well, I'll leave this. So this is negative 9 divided by 3, which is negative 3. So that's going to be negative 3. And so negative 3 times 2 is negative 6. And so this is going to be a negative 6 plus 9, which gives us 3. All right, so when we plug in this 11, it ended up giving us this 3. So the question is that the same number we started with? So 3 and 3. All right, so that makes sense. We plugged in a 3, and in the end we got a 3. So these are inverses. That's the end result. All right, this is the general idea of what you need to know how to do. One is to actually rewrite it, right? So we had all this process of undoing everything, know the difference between equation notation, function notation, swapping your x's and y's, rearranging them, using your algebra skills, and then to actually verify that this is actually the inverse. I didn't write it down here, but I guess I should include that. So this is the inverse. Don't assume, like, it is very possible we could have made a mistake and maybe we would have had a minus 9 here and we would have thought, oh yeah, that's correct. But not until we actually test it out would we know for sure if it was the inverse. So if we would have had a minus 9 at the end here, then we would have been getting different results, which is not good. All right, so we would have ended up having a negative, I think what was a negative 15 as an answer, which would not have been correct. So let me know if you have any questions. Hopefully you have a general idea of how to do this, and we'll see you next time.